Hi students, welcome to Vedantu J English. I am Diksha Ma'am, your chemistry master teacher, and today on your special demand we are going to talk about WBJEE. We are going to pick up some really important questions, some previous year questions. I have picked out some really important questions with the analysis of previous year questions we have taken for WBJEE. For that, first you should know the categories here. So the categories are, if you talk about category 1, category 2, category 3, three kind of questions you will have. I'll talk about chemistry here. In chemistry, you will have 30 questions of category 1 that carries 1 mark, right? And here you will have deduction of -1/4 if there is any wrong answer, right? Category 2, you have 5 questions. That means this is multiplied by 2. That contains 10 marks here. And here, if you answer it wrong, 0.5 marks, that is -half, will be deducted. Right? In category 3, it carries 2 marks question again, but this will be a multiple option. Right? Like these two will be single option, single correct option. This will be multiple options. Right? So that is category 3. This also carries 5 marks multiplied by 2. That is 10. And total you have 50 marks for chemistry here. Right? So today we are going to fight for those chemistry marks here, right? And this is in detail I have given you from your official website. It is in detail regarding category 1, 2, 3. You can go through this. PDF will be provided to you, right? Okay. This is the full syllabus of chemistry, right? PDF will be provided to you. I know right now you must feel that, okay, ma'am, this is not visible to me. But either I can send you the PDF also, but on my Telegram channel that is mentioned over here, right? And also on the official channel of Vedantu JEE English, I'll send you the syllabus of this, right? I'll send you the complete syllabus here, right, regarding chemistry, right, from the official website only, because the syllabus is like, this has a vast syllabus, right? Okay. So I would advise you to at least go through, not all the chapters. If you are prepared for JEE Mains, then there are some topics that were not there in JEE Mains, right? Okay. If you are preparing for JEE Advanced, then so you don't need to do that. But if you are preparing for, if you were preparing for JEE Mains only, then there are some topics that were not there in JEE Mains, but are there in WBJEE, right? Okay. Now let us start the question. So the first question on your screen is, we have, this is the compound, right? And here they are saying this is the double bond, this is C double bond O, O, and this is H, right? Firstly, they are saying you have addition of I2. So what I2 will do? I2 will break this, I2 will break this here, this bond, this will break, and here you will have the addition of I here, right? After this, what will happen? These electrons will jump here, and what you will have? This whole I. Oh, ma'am, you should not try these stunts. Chal, no worries. I'll do again, right? I will not give up. So this is C double bond O. This is OH here, right? We had I over here, that is positive. Now what will happen? These electrons will jump here, and hence you will have this ring here, right? And this is C double bond O, this is OH, because electrons, not from here, but from here, I was about to draw. From here, the electrons will jump, right? Not from here. Wait a minute. Let me just erase that. Not from here, right? Now what will happen here? Now students, what will happen here? Because the electron has jumped from this position, so there will be a positive charge here. And here you will have I, right? Okay. Already you know that on this position, you have I only in B. Here you don't have I. Here you don't have I. So already you know the answer, but still, let us see how we are able to form this thing. So this is positive because of NaHCO3, which is also a base, basic properties it has. So this will take out H positive from here. This is negative, and hence what you will have? This compound will be formed. This is I. This is C. This carbon has double bond O. Is it? Ma'am, this carbon doesn't have double bond O. There is one CH2 group also here, that is C double bond O, OH. This is also CH2. This is C double bond O, O, and then H, right? So here you have this negative. Here you have this negative over here, that is This is O negative. These two will join together, right? And you will have one C here, that is CH2, one C double bond O, then one oxygen which is directly linked here. That is nothing but your compound that we have seen in the B. So answer will be B is the correct answer here. Is that clear to everybody? B is the correct answer. Next question on your screen is, this is an organic compound. They are saying you are adding H2PDBSO4 and you're doing hydrolysis here, right? So let us see what we are going to do here, right? Okay, students. So if you see this here, first you're adding H2PDBSO4 and we know that this is Lindlar's catalyst that is used in Rosenman reduction, but that is also used to convert alkyne to double bond, that is alkene, right? That means this will be converted to alkene here, right? So this will be a double bond, right? After that, you are adding H3O positive, right? Now H3O positive is going to take out this OH negative. So there will be a positive here. So I'll just draw here phenyl. This is carbon which is having positive. This is carbon, double bond carbon. Then there is single bond carbon. Then there is double bond carbon. Then there is OMe. This is what we have here, right? Now, after this, what will happen? As you can see, this phenyl, that is this benzene ring, right, has carbon with the positive charge, right? That is showing resonance. That means it is showing resonance, it is stable. But what if this electron shifts here and this bond shifts here? It will be PH, C, double bond C, single bond, double bond. This is C, positive will be shifted here. Now you will say, ma'am, if that was stable due to resonance, then what was the need, right? So what was the need here, ma'am? Right? If you see, here you can see back bonding. And we know from Barhi, this is the order of stability of intermediates, right? Barhi means back bonding, aromaticity, resonance, hyperconjugation, inductive effect. That means back bonding has more priority as compared to resonance. That means this carbocation will be preferred here, right? Then you have OH negative in the solution also, right? So again, what will happen? This OH negative will attach here, right? OH negative will attach here, right? Once OH negative will attach here, we again have water in the solution. So what will happen? This methyl group will also be converted to, in the acidic condition, that will be converted to hydrogen. And when on one carbon you have two OH here, it is not able to handle. So what will happen? OH negative will be eliminated, H will be eliminated, double bond will shift here, and this will be converted to, here you must have one hydrogen also to complete the valency already, right? So here what will happen? This will be eliminated, this will be eliminated, double bond will be shifted, and this will be C double bond O. That means PHC double bond, PHC double bond, then you have single bond. Wait a minute, that means here you have two double bonds here, right? So you can say CH double bond CH, then again you have CH double bond CH. So can I write it as, can I write this as, this is PH, this is CH, or you can say C double bond C twice CHO. So that means, can I say C is the correct answer? Right, students? So answer will be C is your correct answer here. Is that clear? Okay. Is that clear, students? Next we have the correct order of increasing basic character of the following compounds. Now they are asking you the basic character. So for basic character, what we know, that down the group basic character increases, right? Okay. For hydrides I am talking about. So that's why what will happen? B is going to be the correct answer, because down the group it is decreasing. Nitrogen, phosphorus and so on, right? Okay. Next is, which of the following species is aromatic in nature? Okay, for aromatic, what you should know, that it follows PCC and it has 4n plus 2 pi electrons here, right? So for that, what you are going to do, everybody let me know in the chat box. This is cyclobutadiene. This is cyclobuta. This is having two dienes here. Okay. This is the A part. What is B part? B part is cyclooctav. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So tetra means 1, 2, 3, 4. Okay. C is what? 18 aniline. Okay. Then last one is benzene oxide. Okay. So if you talk about all of these here, aromatic they are asking you. So already which of the following species is aromatic? So when I see 18 aniline, I can easily say this is aromatic in nature. How? Firstly, this is anti-aromatic because it has 4 n-pi electrons. This is non-planar, that is why it is non-aromatic because it exists in a tub-like structure here, right? Tub-like structure like this. Okay. Then, if you talk about this thing here, that is 18 aniline here, right? 18 aniline. In aniline, you have 10, 8 and 12, which are non-planar, so that is why they will be non-aromatic, right? Rest of them can be aromatic or anti-aromatic depending upon the number of electrons. So this has 18 electron, that means it is 4n plus 2 pi, right? That means if you put n is equals to 4, you will get it is equals to 18 electrons. That means you have 4n plus 2 pi. So answer is going to be, this is your aromatic compound. So answer is C is the correct answer. Is that clear? Okay. Yes, students, is that clear? Okay, next question. The ionization enthalpy of oxygen is less than that of nitrogen because, anybody? Ionization enthalpy of oxygen is less than that of nitrogen. What is the reason behind that? What is the reason? Right? See, if you talk about oxygen and nitrogen follows this order, this is nitrogen and this is oxygen. Right? Okay. Ionization enthalpy means to lose the electron. Now, ionization enthalpy of oxygen is less. What is the reason? Why oxygen is easily? Ma'am, this is opposite, ma'am. Because nitrogen is more oxygen is more electronegative. So oxygen in reality, like if you think about this, oxygen is more electronegative. So oxygen should bound the electron. It should be like, I don't want to give my electron because I'm more clever. But in reality, what happens? Nitrogen has more ionization enthalpy. Reason is the small size of oxygen. Because we know that along the period size is decreasing, right? So because of the small size of oxygen and it has 2 lone pair, it has 1 lone pair, that is the reason more electronic repulsions are there. So that is why it is like, take away electron from me as compared to nitrogen. That is why ionization enthalpy of oxygen is less as compared to nitrogen. So answer is electron repulsions in the oxygen is more dominating here, right? Okay. So answer is C is the correct answer. Next is the rate of reaction between A and B is given by this thing. This is the rate of reaction. R is equals to K. This is A, this is B and square. Now they are saying that B is doubled. That means here new rate is going to be K. This is A, this is 2B and this is square. That means this is 4K, this is A, this is B square. So this is quadrupled. R dash is equals to 4 into R. So that is increased by 4 times. That is, it is quadrupled. So answer will be C is the correct answer here. Is that correct? Okay. Is that clear? Yes, students. Now next one. Give test to differentiate 1,1-dichloroethane and 1,2-dichloroethane. 1,1-dichloroethane and 1,2-dichloroethane you have to distinguish here, right? So the best test to distinguish this is going to be, right? Let us see 1,1-dichloro. So according to me, this will be 4-DNP, then aqueous. Let us see how, right? So first thing is, if you have, yes, firstly, yes, aqueous, then you have 4-DNP, that is B. Let us see how. Okay, so this is your 1,1-dichloro, right? This is 1,2-dichloro. In this case, when you replace this with QH, this is replaced by OH, this is replaced by OH. One carbon cannot handle two OH. So OH will be eliminated here, H will be eliminated, you will have a double bond here. That will convert it to aldehyde. Now we know that aldehyde gives 2,4-DNP test because of the carbonyl group, right? But if you see aqueous KOH is replaced in this place, you have OH on different side. Now this OH on adjacent side is not going to give 2,4-DNP test because 2,4-DNP test is given by carbonyl group, right? That is C double bond. So that is why this will be negative test. So answer will be B is the correct way of distinguishes these two compounds here. Right? Next question is, the Prussian blue color obtained during the test of nitrogen by Ligands test is due to the formation of. Now you just have to tell what is the formula of Prussian blue. What is the formula of Prussian blue? Right? Everybody, inside and outside the bracket you have ferric only, that is Fe only, right? Fe and Fe. So answer is A is the correct answer. Fe4, Fe, Cn6, and this is thrice. Okay. So that is going to be the answer here, right? So that is going to be the answer here. That is your Prussian blue color, right? Okay. Very, very famous compound. Very famous compound. Right? Is that clear to everybody? Right? It has one ferric and it has one like one iron is in +3 oxidation state and one is in +2 oxidation state. That's why this is an extremely important compound, right? Next question is, given below are the oxides, these are oxides given to you, number of neutral oxides you have to identify here. Number of neutral oxides. Neutral oxides, if you see, this is neutral, and CO is also neutral. So, but CO is not given here. So out of this, only 2 oxides are neutral. So answer will be 2. But you should remember that water and CO, NO and N2O all are neutral. I'm going to write it here. H2O, CO, NO and N2O. This is NO and this is N2O. All are neutral oxides. All are neutral oxides here. Right? Is that clear? Okay. Next we have, which of the following statements are correct here? So the statements are both LiCl and MgCl2 are soluble in ethanol, right? Oxides of Li2O and MgO combine with excess of oxygen to give superoxide. LiF is correct and incorrect statements are very frequently asked in WBJEE, right? Like 3-4 questions will be there based on correct and incorrect statement. So if you see this here, both LiCl and MgCl2 are soluble in ethanol. That is the correct statement. Then you have the oxides of Li2 and this combined with excess of oxygen to give given superoxide. No. LiF is less soluble in water than other alkali metal fluorides here, right? Which is correct. Very, very important statement. Right? Next is Li2 is more soluble in water than alkali metal. That does not true. That is not true for other statements. That is not true for oxygens here, but that is true for fluorine here. So answer will be A and C is the correct answer, right? Next is, in a given reaction sequence, the major product C they are asking you, right? So if you see this here, they have given you in all the compounds, you have benzene here, right? That means for sure in this compound, you should have benzene. So that means C8H10, you will subtract benzene, that is C6H5 from here. Ma'am, benzene is C6H6. One hydrogen will have the substituted compound also, right? Okay. So C6H5 is substituted. So that is H5. And here you have C2. That means ethyl is the, ethyl can be the compound here, which is the substituted part, right? Okay. Right. So here we can see that this C8H10 is nothing but CH2CH. Let us see if we are able to find this if you assume this to be CCOH5, right? On nitration, what you will have on the ortho position and on the para position, you will have it. But para is always the major, that is more stable if there is no hydrogen bonding because of the symmetry, right? After that, you are adding Br2 here. Now, students, if you see this here, whenever you are adding Br2, this particular compound is meta-directing. This compound is ortho-para directing. Wait a minute. Wait a minute. Okay. This compound is ortho-para directing. But you know what's the problem? Not the problem. The thing is, this is not bromination. This they are doing is H mu. Heat they are doing, right? Whenever you have helper, that is HELPR. That means either you have heat or electricity or light or any peroxide or any radical. This is going to give you free radical mechanism. So by that there will be benzylic substitution. That means this is the benzylic position. This will be substituted. Then you add alcoholic QH. That means Br will be substituted. H will be substituted. So there will be a double bond here. So answer should be B, the correct answer. I think answer is B only. So answer is going to be B is the correct answer here, right? You should have knowledge of reagent. That is a must thing, right? Knowledge of reagent is must. Next is, for a first order reaction, the time required for completion of 90% reaction. 90% reaction is X time. That of half reaction, right? You have to find the value of X. So when you say T is equals to 2.303 by K, this is log, right? Log of initial is 100. When you have in percentage, if you're saying 90% is consumed, then 10% will be left. So it will be 10, right? So you can put here log 10. Log 10 is nothing but it is 1. Okay, log 10 is nothing but it is 1. Log base 10, 10 is 1, right? We know that T half is equals to 0.693 divided by K. So K will be equals to 0.693 divided by T half. So I'll just put it here. K is equals to 0.693 divided by half. Okay, right? Now you have to find, they are saying what is this value of this X. This is what they are saying X. So they are saying what the first order reaction time required, this time, right? X times T half. So this is the X that you have to find. That is the value of 2.303 divided by 0.6. You have to find this value. And with that, you will get the value is 3.32. And the answer is going to be B. C is the correct answer here, right? Next question is solute A. Next question is solute A associates in water. So if I say solute A is associating in water, that means association is happening. 0.7 gram of solute, that means W2 is given to you, is dissolved in this much of water, W1 is given to you. It depresses the freezing point by 0.2, that is delta TF is given to you. Percentage associated of A in water you have to tell. Delta TF is equals to I. Molality is what? Number of moles, that is W2 by M2 multiplied by W1 multiplied by 1000 here, and this is Kf. Right? If you see this here, everything is given to you, right? M2, if you see W2 is given to you, W1 is given to you, Kf is given to you, delta Tf is given to you, right? And here, what is the value of M2 here? Let me see. Solute A associates when this of A dissolved in this of water. It depresses the percentage association of solute A in water. Molar mass of A is given to you here, right? That is given to be 93. That is given over here, right? Okay. That means you have to easily, you can find the value of I here. So I you can easily find from here. Right? Once you find the value of I here, then what is the next thing? To answer the association, right? For association, when nothing is given to you, you will take n value as 2. That is, it is getting dimerized. If nothing is given, you will take it as dimerization, right? Now you have to use the formula of alpha, I and N here. That is going to be very simple. That is alpha is equals to I minus 1 divided by 1 minus 1 by N minus 1. I minus 1 by N minus 1 directly. Okay. So N, I told you it is 2. I, you can solve it from here and you will get the value of alpha. If this is given in percentage here, so 0.8 means 0.8 multiplied by 100, that is going to be 80%, right? So answer will be 80% is the correct answer here. Got it? Next question is, in 3D series, the metal having the highest standard electrode potential. See, there is highest standard electrode potential, among this is copper. And you know, this is also the highest, even if among the options also, it is highest. But among the 3D series, they are asking you, that is also the highest, because that is positive of 0.34. That is the only positive potential that you have. So answer will be C is the correct answer here. Right. Next question is, the f orbitals are half and completely filled respectively in lanthanoid ions. Given atomic number is given to you, this and that is given to you. They are saying the f orbitals are half, that is F7, and completely filled, that is F14. For this, you should understand this particular thing, that is the stable. Okay. Here, if you see, lanthanoid 4 is 0 and 7. This you should remember. Lanthanoid C 0, 7 and 14. This you should remember. Lanthanoid 2 is when it is 7 and when it is 14. That you should remember. So if you see, this is 14 at ytterbium. Right, I'll just write this is 14 at ytterbium. This is 7 at europium. Right, europium 2 positive, ytterbium 2 positive. That makes it 7 and 14. That is stable configurations. This is lanthanum 3 positive. This is the gadolinium 3 positive. This is the lutetium 3 positive. This here, students, it is terbium 4 positive. Right, I'll just write it here. Terbium 4 positive. And here it is cerium 4 positive. So they are asking you half filled here. Half filled, you have europium, you have gadolinium, and then you have terbium. Right? Half filled is europium, you have gadolinium, and then you have tritium. That means these two are half filled. Fully filled, they are asking you, right? Fully filled is what? Fully filled is you have lutetium and you have ytterbium. That is ytterbium 2 positive is the fully filled here. So answer will be C is the correct answer. And what are the electronic configurations that you should remember? 1, 2, 3, 4, 5, 6, 7. That is a must remember electronic configuration for your exam, right? Okay. Next question is, which of one of the following compounds is inactive towards SN1 reaction? So if you talk about SN1 reaction, so in SN1 reaction, we know that this is two-step. That means there is a formation of carbocation, right? There is a formation of carbocation here. So the least stable, inactive means you have to find the unstable carbocation. Unstable carbocation, this is tertiary carbocation, that is definitely stable. This will be allylic carbocation, that is also very stable, right? Then there is the, if you lose it here, then you will get this kind of compound that is going to give you positive on the bridgehead, right? Positive on the bridgehead. And bridgehead means it will be sp2. And bridgehead sp2 is never stable. So here we can say this is the inactive towards SN1. If you see this here, it will give you positive here. That is the resonance stabilized. Resonance stabilized. So again, it is a stable carbocation, right? So answer will be C is going to give you unstable carbocation here, right? Okay. Next question is, consider the species, these three species are given to you and they are saying that choose the correct option with respect to these species. You have to choose the correct option here, right? So choosing the correct option, they are isoelectronic. First we calculate the electron, 6 plus 4 that is 10. This is 7 plus 4 minus 1 that is 10. This is 5 plus 4 plus 1, that is 10. Right? Boron is 5. Right? So that means they are definitely isoelectronic. Right? 2 are isoelectronic, no. 2 are isoelectronic, no. Now let us see if they have tetrahedral structures or not. Right? If you see, we know that this has tetrahedral, this also has tetrahedral, this also has tetrahedral structure. So yes, all of them has tetrahedral structure. So answer will be both. B is the correct answer here. Right? Okay. Next question, students. Which of the following compounds has maximum pK? Now, if you see pK value, that is inversely proportional to acidity, right? Which is inversely proportional to basicity. So basically, they are asking you the maximum basic character. Maximum basic character they are asking you indirectly, right? So we know that basic character is directly proportional to electron availability here, right? If you see here, the electrons are involved in the delocalization. Here the electrons are not involved in the delocalization. Here the electrons are involved in the delocalization in two sides. Okay, so what can happen either to this side or to this side. This is the definitely not available. Right? So here also it is involved in delocalization. Here you have minus M and minus I effect also. Right? So if you talk about the one that is going to show you, minimum, that is maximum electron density on the nitrogen availability, electron will be maximum available on B. So B is going to be the maximum basic, that is maximum pKa value here. Right? Okay. Next question is, for a first order reaction. For a first order reaction, students, everybody, let us see this question here. Let us see this here. For a first order reaction, choose the correct value of half-life. Okay, so you have to choose the correct value of half-life here. So if you see this here, T half, this is the first order reaction. We know that T half is equals to 0.693 divided by K. You have to solve the value of K here. And you know what we also know? Graph is given to you. So graphically, let's solve this. We know that the equation of log A by T final concentration, that is K is equals to, this is 2.303, this is divided by T, so you can also put it as, this will be KT 2.303 divided by 2.303 equals to log of initial by final, this can be A0 by log of AT, right? Okay. So if you try to find the log of AT here, log of AT will be equals to log of A0, that is the initial concentration, right? You can also put it here capital log of, let me just put it, this will be log of A0 minus log of AT. Why? Because log of A0 divided by AT is equals to log of A0 minus AT, right? That means log of x divided by y is nothing but it is log of x plus log of y. That is a property of log, right? So here it is log AT will be, here it will be minus k by 2.303 and this is t. So if you put this in the form of straight line equation, that is y equals to, this is intercept c, this is m and this is x. So slope is going to be this. That means m value is going to be, slope is going to be minus k by 2.303, right? Okay, that is t here. That is equals to tan of theta, right? We know that slope is equals to tan of theta. Tan theta, students, we know that tan theta, that is tan 35 is nothing but it is tan 180 minus 45. Tan of 45 is 1, then tan of 180 minus 45. If tan of x is y, then tan of 180 minus x will be minus 5. Right? So it will be minus 1 here. Right? Okay, you will put one negative. So that is totally opposite in the quadrant. Right? So you have studied trigonometry already. So that will be tan of 135. So we can write here that is minus 1. So this is minus 1, this is minus k by 2.303. So k value will be 2.303. I hope so I have not done any calculation mistake here, right? So if you put this here, T half is going to be 0.693 divided by 2.303, and that is going to be your answer, right? That is going to be your answer, right? Okay, yes, k value is this, and you will get the value of T half. Dividing this, you will get your answer here. Is that clear to everybody or not? Understood, students? Is that clear? Right? Okay. Next question is x and y respectively are. So now they have given you this thing. So if you see, this is nothing but this is diazotization. So basically what we are doing, we are making disonium salt here, that is N2X is what we are making here, right? After that, you are adding Cu2X2. That means Sand-Meier's reaction you are doing. So that is converted to that aryl halide. So X is what? Benzene disonium halide. And this is not alkyl, this is aryl halide. So answer will be benzene disonium halide and aryl halide is the correct answer. So answer is B is the correct answer here. Right? Next question is the difference between delta H and delta U. So one thing to remember, delta H is also QP, delta U is also QB. Right? That you should remember. They can also give you heat at constant pressure, heat at constant volume. This also can be given to you. Right? The difference between delta H and delta U when the combustion of 1 mole of heptane is carried out at temperature T is equals to. You see this here. Delta H is equal minus delta U. Delta H is equals to delta U minus delta NGRT. That means if you have to find delta H minus delta U, that is equals to minus delta NGRT. So now you just have to calculate the value of delta Ng here, otherwise the values are in this only. They have given you combustion of 1 mole of heptane, right? So heptane is C7H14 plus 2, 16. This is what you have to do. So directly, what will be the formula here? What will be the reaction? This is the reaction, okay? Right? Now, if you want to learn the direct method, then whenever you have CXHY and whenever you add X plus Y by 4, that is for alkane. You will get X amount of CO2, you will have Y by 2 amount of this. X and Y values you will get to know from the X value is 7 here, Y value is 16 here. Right? So put 7, this is 16, this will be 4. So 7 plus 4 is nothing but that is 11. Put 7 here, put 16 here, so that will be 8. Right? So that is how you will get your equation here. That is the general equation that you should know. Right? So now here delta Ng will be equals to gaseous, that is 7. Here gaseous is 11, so 7 minus 11, that is minus 4. Once you put it here, what you will get here, that is, wait a minute, delta H is delta U plus delta, that is plus delta NGRT, right? So this will be plus here. So here answer is going to be minus 4 RT. So answer is going to be A is the correct answer, okay? Right? Next question is, a diatomic gas at pressure P compressed adiabatically to half of its volume. Now here you will use adiabatic, right? Adiabatic, for this, if they are asking you diatomic gas, so compressed adiabatic to half of its volume means V2 is equals to half of V1, right? That is given to you. They are asking you, you have to find the value of P and V in relation to gamma, because diatomic gas is given to you. Gamma value you already know for diatomic gas. So what we will do, we know the gamma value here for diatomic gas, that is 1.4, right? That is 1.4. So directly what we will do, P1 V1 gamma, P2 V2 gamma, V2 is given in terms of V1. V1 V1 will cancel each other because V2 is equal to half by V1. So you can put the value of gamma here. P2 they are asking you, P1 they have given you. No, P1 they have given you. P1 is considered to be P here, pressure P. So put P1 as P here, right? I'll rather put it as P. So this will be cancelled. This will be 2 raised to power 1.4, and that is how they are asking you answer in that only. You don't have to solve that. They are asking you answer in that only. So answer will be A is the correct answer here, right? Next question is, out of these 4 species, the colorless species they are asking you. Colorless species means what? Colorless species means what? Colorless means the one that do not have any DD transition. That means D0 or D10, right? So if you see this here, the first is going to be, this is going to be 2x minus 2 is equals to 0. So x is going to be positive, right? We know that here copper positive. See, copper is 4s1 3d10. Copper positive will be 3d10. So that is definitely under this category. That means this is colorless, this is colorless, right? So chances are out of these two you will get any of the answer, right? I feel this should be the answer, but still let us see, because second option will be answer if both of them are the like under the category of options like eliminated. After eliminating you have. So this is x minus 4 is equals to minus 2, x is equals to plus 2, right? X is equals to plus 2. Now, if you see this here, x is equals to plus 2. So, can I say that here x is equals to plus 2? Nickel, we know that that is 4s2 3d8. Plus 2 means it will be 3d8, right? It is 3d8, not possible, right? What about this? X minus 6 is equals to minus 2. That means x is equals to plus 4, right? So titanium, that is oxidation, that is atomic number 22, 4s2, 3d2. After losing 4 electrons, it will be 3d0. That is under this category. So answer will be B is the colorless compound category here, right? Okay. Okay, students, still here, do you have any problem or not? Let me know in the chat box if there is any problem till here. If there is any problem till here, then let me know in the chat box. Next is the calculating magnetic moments for species. 3 species are given to you. They are asking you to calculate the magnetic moments here, right? So if you see this here, firstly let us calculate for this one. That is xc. Simple is, this is x minus 4 is equals to minus 2. So x is equals to plus 2. Iron is 4s2 3d6. In plus 2, it will be 3d6 here, right? What about this one? What about this one? This is x minus, here it is what? Here it is x minus, so here it is going to be C2O for minus 2. So minus 6 is going to be minus 3, so x is plus 3. So cobalt is what? 4s2 3d7 plus 3 means this is going to be 3d6 here, right? Okay. What about this one? What about this one? If you see, both are 3d6 only, right? Both are coming out to be 3d6 only. Okay. Now, if you see here, this is x minus 8 is equals to minus 2. X is equals to plus 4. So, manganese is what? Manganese is 4s2 3d5. When you take out 4 electrons, it will be 3d3. Okay. So, now let us see the pairings here. If you see, this is a weak field ligand, weak field. So there is no pairing. So it will be, if you have this Fp here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. That means you will have 4 unpaired electrons. So mu is going to be 4.9. This is not possible. This is not possible. Either this or this, right? 4.9. See, first digit point, first the number of unpaired electron point, either you can write 7, 8, 9. That will be your answer. Okay. Right. So here it is. If you talk about here, it is 0 and here also it is 0. For this, we don't even need to calculate, but still I'll tell you. For coordination, whenever you have cobalt 3 positive, in that case, when you have cobalt 3 positive, oxalato and water behaves as strong field ligand. That is the exception. Okay. So that is why this is behaving as strong field ligand. It will cause pairing. So it will be 1, 2, 3, 4, 5, 6. 0 unpaired electrons you will have. Now let us see whether here you have 2 unpaired electrons or 3. That depends upon whether there will be pairing or there will be, whether there will be pairing or whether there will be no pairing here. Right, wait a minute, let me just see. This is minus 8, this is equals to minus 2, right? This should be plus 6 here. Because we don't have any ligand here. How can we decide the pairing or not? Right? So this is plus 3. So manganese is 4s2, 3d5. You take out 6 electrons, 2 from here, 4 from here. That will be 3d1. So that is 1 unpaired electron. That means the answer is going to be this. That is C is the correct answer. Is that clear? Okay. Understood? Next question is the hybridization and magnetic nature of FeCN63 negative. So that is, if you talk about the hybridization here, what we are going to do? This is x minus 6 is equals to minus 3, x is equals to plus 3 here. Directly what we will do, x is equals to plus 3, that simply means iron, that is 4s2, 3d6, that exists in plus 3 oxidation state, that means it is 3d5. That means it is 3d5, right? Now what we will do, if it is 3d5 here, now what we will do, right? If it is 3d5 here, simply what we are going to do, in this case, it is a strong field ligand. So that is why it is going to be 1, 2, 3, 4, 5. That means it is definitely paramagnetic in nature, right? And here you will have D2sp3 for coordination 6. Either it can be D2sp3 or sp3d2. So here it will be D2sp3. So answer will be B is the correct answer here. Is that clear to everybody or not? Is that clear to everybody or not? Yes, students, right? Okay. Next we have is the correct order of intensity of colors of the compound, right? Colors of the compounds, if you see this here, intensity is equals to, if you talk about the intensity of color, that means the wavelength they are asking you, right? So E is equals to h mu, that is hc by lambda. So E and lambda are inversely proportional. So stronger ligand will have less wavelength, less intensity. Cn is the strongest among them, that will have less intensity. Cl is the weakest, that will have maximum. So answer will be B is the correct answer here. Okay, B is the correct answer here. Right? Is that clear? Is that clear to everybody? Right? Intensity defines the amplitude, right? Okay, and that is defined by the wavelength. That is why. Okay. So among the following, so these are the molecules that is given to you, and they are saying which one is diamagnetic and has shortest bond length. Shortest bond length they are asking you here, right? See, we know that bond order is inversely proportional to bond length here, right? So you have to click the bond order. First is pick the longest, pick the largest bond order here, which has largest bond order. So if you see, this is 8 plus 2, this is 16. Number of electron is 16 here as well. Number of electron is 16 plus 2, 18. Number of electron is 12 plus 2, that is 14. So we know that for 14, the bond order is 3. So this is 3. As you go down, 16, 17, 18, it will decrease by 0.5, 0.5. This is 2.5 to 1.51. As you come here, this is 12, 11, 10. This will decrease by 0.5, that is 2. This is 1.5 and this is 1 here. Right? Okay. Now what you will see, 18 is nothing, that is 1. 16 is 2 and here 16 is 2. So largest bond order is for C2 negative. That means this is the largest bond order. So it will have the shortest bond length here. But we also need to find whether this is diamagnetic or not. If this is diamagnetic, that is going to be the answer. So for 14, that is equal to 14. So you will have 2, 1, 2, 1 as your answer. 14 minus 8 electrons, kk electrons you will always subtract, that lies in sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, right? So 8 electrons will be 4, 5, 6 electrons here. So that means here what you are going to have 6 electrons, 1, 2, 3, 4, 5, 6. Okay. That means this is not the correct answer, is it? Let me see that again. Diamagnetic means no unpaired electron. No unpaired. And this is the one that does not have any unpaired electron. That means this is going to be the correct answer here. Right? So answer is D is the correct answer here. Right? Next question is, you have 4 electrode potentials are given to you. They are asking you the reducing power. So always remember, if you talk about reduction potential, that is directly proportional to oxidizing power, right? And that is inversely proportional to reducing power. So reducing power, that means the tendency to get reduced. If I want to get reduced, I would want to oxidize something. That means I'm a good oxidizing agent, right? So let us see whether all of them reduction means oxidation number should decrease. Right? Here it is decreasing, here it is decreasing, here it is decreasing, here it is decreasing. Plus 3 to 0, 1 to 0, 1 to 0, 2 to 0, it is decreasing. All of them are reduction potential. Now they are asking you about reducing power. So the minimum reduction potential is going to have the maximum reducing power. Minimum reduction potential will be for potassium here. So potassium is going to have the maximum reducing power. Then after potassium, you will have chromium, right? Okay. After potassium, you will have chromium. After chromium, you will have Hg, right? Okay. Yes. Then you will have Ag. So answer will be A is the correct answer here. Right? You just need to know this relation and the variations here. That's it. Okay. Next question is, which of the following combination is this suitable for the preparation of 3-methyl-2-butanol? 3-methyl-2-butanol. Okay. So once you see this here, 3-methyl-2-butanol, that is 1, 2, 3, 4. 3-methyl means here you have CH3, 2-butanol. 2 you have OH here. That means on the second position you have OH here. Right? Okay. Okay. Now they are saying what can be formed here if you have 2-butanol plus methyl magnesium bromide. 2-butanol and methyl magnesium bromide, then it is not possible because, wait a minute, then also it is possible also. Or not? No, it is not possible. See, if you have butanol, 2-butanol means you have this thing here, right? If you have Mg, if you have Me, MgBr, that is going to attack here. So OH and CH3 will be on the same position. And here OH and CH3 are not on the same position. So this is not the correct way. Acetone and ethyl magnesium, this is possible. Let us see. CH3, C double bond O, CH3. And here you have C2H5, MgBr, right? That is going to attack here. Electrons will jump here. You will have OH here and this will be C2H5. So again, that is not possible, right? Not possible. Acetaldehyde and isopropyl magnesium, that is possible because we need branching somewhere at least. Okay, this branching should be somewhere, right? Isopropyl 1, 1, 2, this is isopropyl, right? This is CH, this is MgBr. Okay, so when it reacts with acetaldehyde, that means CH3, C double bond O, H. So what will happen? This will be converted to OH, and here you will have the attachment of, if this is converted to OH, I'll just write it here. This is converted to OH, and here you have the attachment of this CH here, right? That will attack on the carbon. So here what you have, this is 1, 2, 3, 4, or you can say 1, 2, 3, 4. On the third position you have methyl, on the second position you have OH. That means this is possible here. That means C is going to be the correct answer here. Okay, that means C is going to be the correct. So you have to solve everything to get the answer, right? Okay, So now there is turn for some previous year question of 2024 only, so that you can get an idea whatever I have taught you, these kind of questions are asked based on reagents and all of these things, right? First is the major product of the following reaction. So they have given you one reagent, that is NaCN here. You know what's the amazing thing about NaCN? That in presence of DMF, right, it does not affect iodine. It affects just the chlorine here. That is why it will replace Cl with Cn here. Iodine will remain intact here. Okay, iodine will remain intact. It will replace Cl with Cn. So answer will be C is the correct answer here. Right? Directly, it's the game of reagents. Okay, wait a minute. Wait a minute. CN. Chal. Next one is, yes, the compound that does not give positive test for nitrogen in the Ligands test. Okay, positive test for nitrogen in the Ligands test. That is, if you see all of this here, this has nitrogen, this has nitrogen, this also has nitrogen. But here, diazonium chloride you have, right, in the form of ions you have, right, in the ionic character you have. You don't have you don't have nitrogen as such in the covalent bonding. So that is why this is not going to give you the Ligands test here, right? We need a nitrogen, right? Okay, so that is only possible in A, B, A, C and D. So answer is does not give is B is the correct answer, right? Next question is the compressibility factor for a van der Waals gas at high pressure. For that, you need to know the real gas equation, that is P plus AN square by V square, V minus NB. Otherwise, you have PV is equals to nRT. But when you have real gas, this factor is added and this is subtracted. That is there in surface chemistry, right? Sorry, states of matter, right? So here what you will see, pressure is very high, so this will be ignored. Okay, that means you will have P multiplied by V minus NB, right, equals to nRT, right? So here we know that means if you solve it, right, because you need to know the value of, let us solve it here. This is PV, this is PV, and this is PNB, right? And this is nRT, right? Okay. Wait a minute. From there you can solve, no? 1 plus PB by RT is going to be the answer. That is for sure. Right? Chalo. PB. Why don't we divide all of this by RT? Why don't we divide all of this by RT directly? Let's divide all of this by RT, and this is also RT. Right? So this will be minus PNB by RT. This is this sure this is N? Yes. Okay. So this is going to be N here, and this is going to be PV by RT. Okay. What you can do here, PV, PNB divided by RT, that is there. And here I feel it will be PV by RT is equals to N plus PNB by RT. Give me a minute. I think this should give us the answer, because that will be N, you can take common, PV by nRT, right? Then it will be 1 plus PV by RT, right? That is your compressibility factor. Z is equals to 1 plus PV by RT. So that is going to be the compressibility. So basically, PV is equals to nRT is ideal gas equation. PV by nRT is your compressibility factor. So that is Z is equals to 1 plus PV by RT. That is B is the correct answer here. Okay, correct answer for compressibility factor here. Right. Next question is for a spontaneous process. Spontaneous process, the incorrect statement they are asking you. See, we know that for spontaneous process, delta G should be negative. Delta S should be considered positive here. Right. So here delta G is positive, that is not correct. Delta G is negative. Delta S is positive, that is also correct. Delta U of the system, right? Internal energy at constant entropy and volume for a spontaneous process should be less than 0, right? For an isochoric process, when you have, so basically what we are saying that let's say delta U is equals to W plus Q plus W, right? If I am saying constant volume, so this is going to be 0, this is going to be equals to Q. And that is the reason, because for a spontaneous process, what you will see, if delta G is negative, right? In that case, right, this is going to be negative and this is also going to be negative, right? So answer will be, that is also the correct thing, right? At constant entropy and volume, if the entropy is constant, right? So in that case, we can say that this is also true. So this is definitely not true, right? The incorrect statement is A is the incorrect statement, right? Next is correct solubility order of this. So for solubility, what you will feel that as you go down the group, right? So here we are talking about fluorine, chlorine, bromine, iodine, right? So down the group size is increasing, right? So that is the reason solubility also is going to, is going to decrease. You know what? Size of Ag and I is increasing, right? Okay. So also you can understand this from the electronegativity point of view. This is fluorine, chlorine, bromine and iodine. If you go down the group, we know that electron negativity is going to decrease. That means the bond of Ag and I, that is a covalent bond, because of the less electron negativities, right? That is also going to get affected here, right? That will be more stronger. Understood? Now that will be more stronger, right? Because the electronegativity is decreasing. That is the reason this F is going to have the maximum solubility here, right? So answer is going to be B is the correct answer here, right? Next question is, what will be the change in acidity if you have two statements here? First is CuSO4 is added in saturated NH4 twice SO4 solution, right? So if you see, when you add CuSO4 in saturated NH4 twice solution, what will happen? Acidity will increase. Reason being because of the common ion effects, right? That is SO4 2 negative, right? The concentration, the Cu with water, because in the solution it is going to be with water, right? So with water it will form a hydrated salt which is acidic in nature. That is why acidity will increase here. This is SbF5 added to anhydrous HF. So if SbH5 is added to HF here, it is going to form SbH6 negative plus H2F positive. And that is the reason, because of these two compounds here, the acidity again is going to increase. So in both the cases, the acidity will increase here, right? Okay. Identify the correct statements here. So regarding the correct statements, oxidation number of Cr and Cr, so simple is, you have double bond here, 1, 2 and 3. It has a butterfly kind of structure. Okay. So here if you see, from here it is -2 plus 2, -1 plus 1, -1 plus 1, -1 plus 1, -1 plus 1. 2, 3, 4, 5, 6. So it is having +6 oxidation state here, right? That is the correct answer. Delta H is greater than delta U for the reaction. So for this reaction, they are saying, provided that both gases behave ideally. See, if you are saying delta U, simple thing is delta H is equals to delta U plus delta NGR, right? If this is 2 minus 1, that is 1 only. If this is 1, that means delta H will be greater than delta U. That is, this is also the correct answer, right? pH of H2. So here simple thing is, here normality is given to you, normality is same. But here n factor is 2, here n factor is 1. According to that, H positive concentration of this will be high. We can say H positive concentration of 1, H positive concentration of 1 will be greater than H positive concentration of this HCl. pH is inversely proportional to that, so that is why pH of 1 will be less than pH of 2. So that is also the correct statement here. Because if the molarity, or you can say the N factor increases, concentration increases, but pH is minus log of concentration, so pH is inversely proportional to the concentration. Okay. Next is RT by F is this. This is a very, very general statement. We have done this in Nernst equation. RT by F is 0.059, that we have put it there, volts, right, at 25 degrees Celsius. So answer will be, all the statements are correct here. This is for 2 marks. Where they told now 2 marks question, right, that will be asked 5 question of 2 marks. This is that question, okay. Which of the following statement about SN2 reaction, SN2 reaction mechanism are true? SN2 reaction. So if you talk about SN2 reaction here, one thing is, in SN2 mechanism, you have carbocation, right? Sorry, in SN2 mechanism, that is, you have transition state, that is a one-step reaction. So in SN2, the rate of reaction increases with increase in nucleophilicity. That is always true. So if nucleophilicity, right, will increase, that means the electron deficiency on that atom will increase, then the attack will increase. That means that is the correct statement. The number 2 denotes a second order reaction. So this means 2 order. SN1 means first order. So this simply means that it is dependent on both nucleophile and the substrate. So that is also true, right? Next one is tert butyl substrate do not follow this mechanism. Tert butyl substrate, yes, tertiary butyl substrate, because see, because of the steric hindrance, they will not follow this mechanism. Because of steric hindrance, they follow SN1, because we know that in SN1 3 degree is more stable, then 2 degree, then 1 degree. In SN2 1 degree is stable, then 2 degree, then 3 degree because of steric hindrance. In SN1 this is stable because of the hyperconjugation, right? Okay, understood. Next part is, this is also true. Next is the optical rotation of substrate always changes from positive to negative and from negative to positive in this place. See what will happen. This is a compound, a tetrahedral compound, right? When you are making this SN2 mechanism here, so what will happen? The leaving group will leave and the incoming nucleophile will attack here, right? Okay. That is the reason there will be Walden inversion here. Okay. So if X is on this side, nucleophile will attack from this side. If X is on this side, nucleophile will attack on this side. Okay. So that is why there is Walden inversion here. Right. So that is also true. So all the statements are true here. It's not like always all the statements are true. It's only in these questions all the statements are true. Right. Okay. Understood? Yes. Next is ozonolysis of orthoxylene produces. Now, what is orthoxylene? On benzene, you have 2 CH3 groups, that is orthoxylene. Okay, this is your toluene. And when on ortho position, you have CH3, that is orthoxylene. Okay. Now, here what will happen? On ozonolysis, 2 things can happen. Like this, it can break the bond, right? So, here you will have this will be double bond O, 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 this will be double bond O. So like this it can break the bond. So here it will be double bond O, here it will be double bond O. That will give you which thing? Okay, that will give you which thing? Okay, according to that, break the double bond, attach double bond O, double bond O, break the double bond, attach double bond O, double bond O, right? So according to that, how many groups you will have? So basically you will have 2 kind of molecules here. First is C double bond O with 1 CH3, right? And 1 CHO group here, right? And then you will have two CHO groups, right? Two CHO groups will be because of this. That is double bond O here, double bond O here. This will give you glyoxyl group. If you see this part here, wait a minute, yes. This is double bond, this is double bond. Break the double bond, this will be double bond O, and this also will be double bond O. That is going to give you this group, right? That is going to give you this group, right? Okay. Wait a minute. Here, this will be double bond O, this will be double bond. That is going to give you this glyoxyl. Glyoxyl. This C double bond O, then you have C double bond O, right? Then you have C, which is having C double bond O, then you have CH is going to give you methyl glyoxyl, right? This here will have double bond O, here also you will have double bond O. So this is one C double bond O, right? Then you have one carbon which has double bond O and then which has CH3. So this also is going to give you the same compound, right? Okay. Next is, let's say double bond positions are opposite. Here you had these positions. Double bond over here. Let's say double bond is not between these two things. Then again double bonds will break here, right? So here it will break and it will give you double bond over here. It will give you double bond over here. So this is the one kind of compound, that is two carbons with double bond O and two CH3 groups over here. That is 1,2-methyl glyoxyl, right? Then here it will give you double bond O. Wait a minute. Here it will give you, after breaking, double bond O, and this is double bond O. That is glyoxyl, right? Here it will give you double bond O and double bond O. That is again glyoxyl, right? So basically what you have to do here, break all the double bonds, right? And where you have single bond, place the double bonds over there, right? Place the double bonds over there. Okay, that is how you're going to have different groups. Now break this. This will be one compound, this will be the other compound, this will be the third compound. That is how you're going to have different compounds. Same here, you do this, right? Attach double bond O everywhere, attach double bond O everywhere. Now break, cross a line through the double bonds. That is 1, 2, 3. So one molecule, second molecule, third molecule. That is how you're going to have all these molecules. Now they are asking you which of the following is not present. See, glyoxyl was present, methyl glyoxyl was present, dimethyl glyoxyl was present. So ethylene glycol is not present. So they are asking you which of the following product is produced here. So A, B and C is produced here. So answer will be A, B, C is the correct answer. Is that correct? Okay. The reactivity order of the following molecules towards SN1 reaction is, this is allyl chloride, so this is C double bond C, this is Cl, this is CCl, right? Then there is chlorobenzene, that is this thing, right? Then there is ethyl chloride, that is CH3, CH2Cl. The first thing is, when you reactivity towards SN1, SN1 means carbocation. So when you take out this, you will have carbocation here. When you take out this, you will have a phenyl cation which is not at all stable. So this will be least stable here. Second is going to be least stable. This is eliminated. This is eliminated. Right? Then out of this, because of resonance, first is going to be maximum stable. So first and third is going to be in middle of that. So answer is B is the correct answer here. Right? The radius of first order orbit. So students, if you see this here, the radius of first order orbit, right? So for this, what you will see, first order orbit, that is n is equals to 1, of hydrogen atom is 53.4. If you see, the radius is 53.4 here, right? And radius of having n is equals to c. So guys, the simple thing is that radius formula is, wait a minute, chalo, I'll just put it here. The formula of radius is R is equals to 53.4, right? In picometer, it is n square by z. N is given to be 1, z is given to be 3 square, that is divided by 9, right? Okay, so that's how n. Radius for first Bohr orbit of night. They are asking you for For a third Bohr orbit, that is 3 square, Z for lithium is equals to hydrogen, helium, lithium, that is 3. So it is going to be 53.4 multiplied by 3, that is approximately 53150. So that is approximately going to be D is the correct answer. Okay. Next, I think this is the last question. I don't know if that is true or not. Let us see. The graph that represents first order reaction. So we know that if we are comparing it with the initial concentration, this will be the initial concentration. So T half we know that is A naught 1 minus N. For first order reaction, this is T half, order is 1. So A naught raised to power 1 minus 1. So T half is independent. That means as the concentration is increasing, there is no effect on the T half. So answer is B is the correct answer here. Okay, so answer will be B is the correct answer here. Okay, students, everybody let me know in the chat box if that is clear to all of you or not. Let me know, students, in the chat box if that is clear. One thing I forgot to tell you, let me just show you that over here. Right? Oh my God, ma'am, so many PDFs you have. Yes, Vita, so many PDFs we have here. Right? Let me just show you that. Okay. First thing is, I want to talk about offline center admissions, because see, if you have any plan of doing JEE, like cracking JEE 2026, right? Okay, then this is a very, very important thing for you, that we are giving you scholarships on in the offline centers. Okay, so these are the offline centers that you can see on this page, right? And here we are giving you 40% scholarship for JEE NEET courses. And students, for all my students here, right, if you want to get 90% scholarship, then get yourself enrolled in MVSAT program. That is the program for scholarship where you can get even 90% scholarship based on the results of your MVSAT. Right? Okay, so register, you can register yourself. The link is in the description. And one more thing for all the students who are preparing for JEE Advanced, then Rank Accelerator book and Eklavya batch is there in the description. Rank Accelerator book is the book where we have really interesting questions for your JEE Advanced. For physics, chemistry and mathematics, it is for some 1600. So that is a very minimal price for these three books, right? And for JEE, if you want any batch for JEE Advanced, then we have Eklavya batch for you, right? Okay, is that clear? Okay, students. Now, I have told you everything about WBJEE. I'll send you the syllabus, right, in the Telegram channel, right? So, everybody do let me know if you want it or not. And also, I want all of you to comment it down. I know you guys won't comment, but still I will ask you to comment it out. WBJEE Chem done. Okay. If that is actually you feel you have done something, then write down WBJEE Chem is done from your side as well. That is a good revision. And students, all the very best for your exam that is going to happen this Sunday, right, 27. So all the very best for all of you, right? Okay. So this is Diksha Kaushal signing off. Bye-bye. Take care. See you all in the next class. Bye-bye.